Hello and welcome back to another video. This time on the A6, Samsung A6, because why not try something different, instead of filling the storage of the my main phone up with yes, I can try. Anyway, let's say you have some Qualcomm BREW based mobile phones with shaky hands, and you want to check the specs on them. I made a program for that. If we make sure to just focus on the blurry image and my shaky hands, it's really fine where the hell I put that tripod thing. And so if we go, I think it's in browse and download on this phone. It's called BrewIt. It's a play on the word. It's a play on the old Check It DOS program, and here it is. Just screen resolution, GUI info, stuff like call depth is 16. Wait. Haha, there's my silly little icon I made. It's also yes, blurry. It's also 16 is that 16-bit color depth? I know these things are kind of slow and stuff, but you know. What if you expect this? This is technically a multimedia phone, so maybe that's some random crap. Tell you the GUI info. Miscellaneous, like how this has about I think that's shaky hands. Now I hate having shaky hands. I'm gonna blame it on the CIA. I am 39 million bytes. Default prompt properties. That's the thing about developing for Qualcomm BREW is there's pretty much zero proper I'm actually gonna it's pretty much no proper way to draw a GUI on here. None. The only halfway decent way, which is why I used for this program, is to call the iHTML viewer. Oh, that's really shaky. Is to does everyone have motion sickness yet? Is to call the HTML viewer function, which I believe actually might be one. I don't know if that code is supplied by the main OS, or if that's one of those things that gets baked into the binary itself. But binaries for Brew are weird. They get like statically linked, and it's kind of confusing figuring out which things are actually going to be system calls or just like extra boilerplate Qualcomm added on. It's not exactly a fun experience. I mean, J2ME, that wasn't exactly the best experience either, but you know, I will say, not big on Java, but you know, I will say, building a GUI with J2ME was honestly pretty straightforward. You just told it to just add like menu buttons and stuff. It kind of just auto places stuff. Not Brew. Is like I mean, for fuck's sake, there's a specialized struct in the programming language where no, let's not do ultra shaky, where the thing where the damn thing just has a proper specialized struct for the rectangles. No. Brew. There we go. Not. Yeah, I don't know what the uptime thing is for. That's the same on both. So legit in the binary itself, if you open it up in a hex editor, you'll just see these strings. That's just HTML code. Because it's the only okay-ish way to draw a freaking GUI on here, and it's a massive pain in the ass. I mean, there's function calls and stuff for drawing buttons and text boxes, but oh boy, that was not funny. That was less fun. I'm starting to see why you had to pay for this software. Benchmarks. You want to see some benchmarks? Did about that many a second for floating signs. And that did that many unsigned longs. And then it's also this thing, this iShell is a branch of kind of a category of kind of system call stuff for like interacting with the system. I mean, there's pretty much nothing remotely, almost nothing remotely like the standard C library. I want to see what this phone's capable of. But there are ways to like MIME types, MIME, like those weird like mail to weird looking URL things. There's ways to kind of do that here, and there's also a mechanism for getting the OS to start an applet via the hex thing of its class ID. Development. Let's talk memory safety for a little bit, along with shaky hands. Can you tell there's a theme right here? Now modern phones, like this and this, they have this wonderful thing called virtual memory, and which basically partitions memory up into pages that can get swapped in and out. And the phone also has this thing called a memory management unit that's in its hardware that makes my hands shaky now. It's kind of hot. Because it's in hardware, it allows like intercepting memory on the fly, and another thing is and it also helps with paging, like committing pages of memory to and from like disk and whatnot, and auto exposure. And it also does another thing, which is partition between physical and virtual memory. Qualcomm BREW does none of that. None of it. I mean, there's some stuff about like if I try to dump that range of memory, it'll cause the phone to reset on account of a memory violation, an access violation, but and that's this is one of the better implementations. On here, as you can see, some of my hard work of figuring out how to write assembly in the kind of god-awful crap that is the GNU inline assembly thing, which is kind of nasty, I'm gonna be honest. That wasn't fun. Have the stack pointer. So even on this phone, there's just large sections of memory. Everything's in physical memory. So that means if something like the web browser closes out, and then something else opens up that's just a tiny bit malicious, and the previous process or the OS doesn't zero that memory out, which it probably doesn't, because kind of slow CPU, then that means any leftover data it can just slurp up. Isn't that just delightful? But anyway, on the Samsung, we also see stack pointer, but we also have the CPSR, or the current program status register. What that is basically the flag register for the ARM thing, and some of them very close to the least significant bits. I think it's the last digit. Uh, signifies what ring the CPU is currently executing in. For the Samsung, that's user mode, so that means the process is running in user mode, uh, which helps prevent just random crap happening. Not much, because it's not exactly the most well designed of operating systems. I mean, it seems to be Qualcomm's chipset seem to have like memory banking, and there's hardware mapped registers for like the NAND flash controllers and the SD card, but and probably for the modems and stuff, but has and there's like this map in the Brew also has this mechanism for a memory mapping system files that were baked into the phone at compile time. Well, there's a function call that allows you to take those and memory map them somewhere, and it also has an option for setting the memory permissions like read, write, and execute. So there seems to be some memory protection going on, but like both of these phones, I can't access the very upper last 64K of memory, which is FFFF0000, which on ARM processors holds the essentially the reset vector program, the boot ROM. I can't get down trying to read from there doesn't work. It resets the phones. But on this phone, little bit spicier, because we're running in supervisor mode. That's right, someone at LG decided to skip the whole ordeal of dropping the CPU down to user mode when entering a user land processes. So that means, I shit you not, you can read giant ass sections of the phone's memory map with zero issues. Even the ones that are hooked up to absolutely nothing. No, seriously, there's large sections of the memory map that the CPU tries to access. Nothing will happen because, well, nothing's listening on the addresses, so you just read back, well, just meaningless patterns, noise essentially. And this phone just lets you do that. I really hope. So if you used an LG Voyager in the early 2010s for any of your banking, actually you don't really have anything to worry about, because I'm sure all those bank cards are now expired. But you get the drift. Hope you won't do any CIA or NSA level stuff on one of these. File copy. Interesting thing. I also have some specialized things for dumping the myths, which are basically the program descriptors. There's also no address randomization. Yeah. So another thing is files can be kind of statically linked into the kernel, I guess. I guess that's what you would call it, like the Java runtime on this and the web browsers on both of these phones appear to be baked right into the kernel itself. There's not like a mod file somewhere on the file system that has like brew Polaris 6.mod. That doesn't seem to exist, but the myths do. They show up. Yeah, files can be baked into the kernel for some reason, and then they also show up. It's a fever dream, really. Directory listing. Yeah, you can list the directories. That seemed like an important thing. Oh, that's about it. And yeah, it's a tiny little program. Oh, as a bit of the process of learning to develop for the Brew, Conway's Game of Life, anyone? Actually runs really well on here. I know it's only pushing like not that many pixels, but that's still quite impressive. So actually, flickers so fast that the pixels kind of do the gray thing with it because it's being essentially pulse width modulated. But yeah, I will say this phone's this Samsung's not that much of a slouch. And neither is the LG Voyager, although I will say for some reason that's kind of not as 120 Hz 4K res as the Samsung for some reason. Maybe slightly less efficient display drawing subroutines, or maybe it's just that. No, I remember actually reducing the dimensions similar to this one, and it made no difference. So it must be some weird subroutine thing with drawing to the display, because the CPU in this thing is actually quite a bit faster than this the Samsung. So yeah, that's about it. I'll put the thing in the description, the link to the GitHub with the program.